Hi, everybody. Thank you for tuning in. My name is Joaquin Milata, and I'm the host. With me today is Dave Dugal, founder and CEO of Enterprise Web. And alongside Dave is Bill Malik. He's the chief systems architect for Enterprise Web. I'd love to give you a chance to introduce yourselves.
Oh, great. So I'm Dave Dugal. I'm the founder and CEO of Enterprise Web. Great to be back with you, Joaquin. I really appreciated our last session. It was a great talk, and hopefully, people who joined today will have watched that or we'll circle back to it. I'm sure you got the link out there. And I'll quickly pass the baton to Bill, who's our chief system architect. Bill, why don't you give him a quick my background, I'm sorry, my background is building, growing, turning around companies. And I founded Enterprise Web with the notion that 20th, that even though it's 2024, we were building essentially 20th century automation systems instead of 21st century automation systems. My thesis was the silos are the enemy of agility, and that we had to come up with much more horizontal, loosely coupled, dynamic architectures that were aligned or congruent with the underlying sort of cloud-based and distributed systems infrastructure, the changing nature of networks, et cetera. And that's what we went on to do. And we have 20 awarded patents for the applications of graphs, particularly hypergraphs, for metaprogramming and their use in a declarative platform for intelligent business and infrastructure applications. So that's a mouthful, but a little bit of background. Back to you, Bill.
Yeah, and I'm Bill Malik, Chief System Architect with Enterprise Web. But my background is in generative technology, sort of generally. Nowadays, you apply it a lot to Gen AI and things like hypergraphs and so on. But my background comes even a little bit lower than that, the fundamentals that sort of make that possible. So, looking forward to today's conversations.
Yeah. So with Bill, we're really implementing computer science first principles. I think I mentioned to you, Joaquin, earlier. I actually found Bill through a paper he had contributed to I'm pretty sure it's a Workflow Management Coalition Handbook of 2008, where he had written a paper on dynamic interoperability in healthcare settings. And you have to imagine, I had read, prior to that moment when I found his paper, I had read hundreds of academic papers going back to Turing, right? Looking at how the original thinkers were thinking these things as thought experiments about how computation should be done before the infrastructure could even support it. So from the 40s, 50s, 60s, 70s, right? All the great computer scientists. But there weren't, in our era, a lot of people talking about the new approach, right? And almost imagine in 2008, when I always start thinking about forming Enterprise Web, is in the 2007, 2008 period. It's the height of the REST versus SOA wars. It's almost the beginning of semantic web versus LPG, and there were lots of arguments going on in those communities as well. And we looked at both of those and said, "My gosh, this is just silly." Computer science and engineering aren't dogma; they're about fitness for purpose. And if you want to do distributed systems, you're going to need high-level abstractions for developers so that they have common models and shared libraries so they can work across end-to-end problems, abstracting away the distributed systems complexity itself.
I,
And so that was sort of the beginning of Enterprise Web, was that kind of thinking, and it was almost indulgent to go down that path, to have the luxury. Thankfully, I had done well previously in my career, and I had the time and resources to start this out. And Bill and I probably spent 2 years just at my kitchen table, pretty much.
nice.
Flying Bill in and out of New York from Canada, so that we could work through abstractions on whiteboards. And you should have seen us back then. It's just like bringing in all the patterns and the abstract and like how it all have to tie together, because it's like making like a Swiss watch, right? The movement is critical, right? Any one piece of the Swiss watch is off. Any misengineering of the gear, right, or anything like, it's going to throw off the whole timing, right? And so you actually have to, when you're building something very complex, it's not uncommon that you have to reason through the problem space together, sort of laterally. You have to think through the problems laterally. You can't just say, take this problem off the shelf in a reductionist way, solve this. Then they take this problem, solve
They're
that.
isolated, fragmented pieces of the whole puzzle, of the whole view of what you need to solve for. I'd love to just lay some context and start from the hero's journey perspective. Uh, Dave was an executive and he was looking to solve his own problem. Um, you were sort of looking at the enterprise and asking, can I see this? Can I see that? What happened here? What happened there? And you were sort of just, you were frustrated with the limitations of the systems that were currently existing. People told you we can, but it would require this amount of time to produce this sort of report, and it won't be fresh. You'll have stale data coming in, stale reports. You didn't have information at your fingertips. You didn't have expressivity as to how to extend your systems. There were a lot of problems with the way that things were being done. As you said, it was sort of in the previous century, despite the fact that we've had so many innovations in hardware and software that allows the thinking, the romantic, idealistic thinking of the early philosophers of computer science. We have the capabilities to implement those things now. People were still just implementing tools and shadows of what existed at the time. So you went and you procured hundreds of dissertations. You went out of your way to really fundamentally understand at its core, how do you represent the world in the most simplified constituent parts, and then how do you implement those details in some sort of technical format to create an enterprise web, hence the name, right? Enterprise web.
Yeah.
But tell me,
I swear, Joaquin, you do this better than I do. But
please,
yeah, I'm just gonna say yes.
you're kind, man. So yeah, right now, where are we today? You've been writing enterprise web for how long?
So the company's formed in March 2009. Actually, originally formed under the name Consilience International, and but nobody knew what that word meant or even how to spell it. But speaking of romantic, and I've been accused of that before, is Consilience is from the title of a book by evolutionary biologist E.O. Wilson, Consilience, but it's a Greek word. It means it means like the lightning connection of across ideas. And I was like, oh, that's exactly enterprise web, right? Enterprise web is this linking, this cross-functional linking of concepts. And but when I came out with it, it was literally Consilience, international.com. I mean, that was just like the worst domain name ever. And so I would get chided for that in enterprise. And then I was like, okay, well, let's step that back a little bit. And I was, thinking about things. Obviously, semantic web was in my head, semantics in general, web architectures, remember the web itself, forgetting semantic web, the web itself is a network architecture. And so thinking about the enterprise as a network architecture, and the idea, the key about including enterprise in the name was we were strongly grounded by enterprise concerns, right? And that's essentially the non-functional concerns, right? That's security, identity, IT governance, it's reliable messaging, it's transactional guarantees, it's state management, but it's also business compliance, right? It's those things that need to cut across. Historically, that's called the non-functional concerns or the cross-cutting concerns in computer science. There was an area of it for object orientation called aspect-oriented programming. But historically, cutting policies across applications has been very hard, right? Because as a business, again, you went back to my motivations. As a business guy, I might have lots of lines of business. I might have lots of activities going on, but I'm still one company. I still want to have centralized visibility and collective policy management. I want to be able to insert or inject those things across. I want to do that efficiently. Historically, the cross-cutting concerns literally have to be wired into each stack, right? So you build these stacks, and then you try to implement the policies into each stack. And then, of course, now you have to maintain the stack, maintain the application, maintain the policies. But the stacks and the applications and the policies aren't evolving at the same time. So now you get this compounding headache when you try to take that architecture. And keep in mind, that architecture is still the dominant architecture of our time. 2024, and go into any major enterprise, and it's stacks galore, vertically integrated, tightly coupled, imperatively coded stacks. They might now have some combination of cloud native tool chains and middleware components, but it's still a stack architecture fundamentally. And that's what we knew was the impedance mismatch, right?
I want to say, with all the time that you've been spending on implementing these enterprise web systems, what has been the biggest learning or insight that you can provide someone who's undergoing that transformation? Like, what is the biggest mindset shift? And with asking that question, I'm also going to put the we're taking questions now ticker at the bottom. But please, I'd love to hear your thoughts and your lessons learned.
Okay, yeah, fantastic. So we've learned a lot of lessons, and it's really been the now. What's really interesting is the core physics or metaphysics of enterprise webs. How it actually works has really gone unchanged since our first patent, right? It's the extensions of it, right? Because we have such a sort of pure model for the system and how it comes together. It's hyper efficient on storage. It's hyper efficient on processing, right? It's so we took a lot of time to get that right. Getting that right then gave us a sort of a platform that we could build on, a platform abstraction. I mean, now from a technical perspective, that we can build up on. In the beginning, our probably biggest problem, going back to even the name, was we were so high on our ideas, or actually, I'll spare Bill. I was so high on these ideas. I was so excited about them and about communicating them, the ideas as I knew them. Nobody else could relate to me, right? And people, and and even though we were demonstrating to people, we learned very early on from just the feedback, the signals that would come back to us is that, oh, we have to raise this, right? We have to make this really easy for people. It's not, I don't think we were ever trying to be the smartest person in the room. I'm not even saying that. I'm just saying my point is that it's not a customer or a prospect's problem if they don't adopt your technology. It's your problem.
Yeah.
And also I take that as a business guy. The problems of my business are my problems. They're not my customers' problems. If it's a technology problem, it's my problem. If it's a communication problem, it's my problem. If it's a UI or a user experience problem, that's my problem too. It's my job to align with the industry and give things to people in a way that they can consume that. That evolutionary journey continues. And I got to say, it continues. And I had a conversation with a great guy that we both know, Nikki Clark. I think I just introduced him to you recently. And Nikki is a great person. But I was just talking to him about that today, is that as consider, you asked when I started. The company starts in March 2009. That's pre-cloud. Cloud doesn't take off to 2012. That's pre-Kubernetes. That's 2016. That's pre-Lambda and all that stuff. That's like 17, 18, microservices, things like that. So those are commonly accepted languages. We pretend like those things have been around forever. This notion of horizontal, elastically scalable resources, and these little elements that come together, right? The way that people talk about disaggregation and distribution, that's evolved a lot over the last 10, 12 years. And what's nice about that evolution of the greater community and the greater industry, just like semantic web people have evolved their thinking, and LPG people, everybody's constantly evolving their thinking, so we don't live in a vacuum. What's nice about that is, as people have taken on cloud computing and had more experience with distributed systems, a common language has evolved where we can communicate our ideas more easily, and we can communicate our capabilities more easily. So communicating enterprise web, let's use an example, graph. Right? Graph's been around a really long time, right? Going back to Aristotle, Plato, computer graph theory, 1700s, whatever. And now it's, go back to semantic web and Aura Lacilla and all those great folks there. And LP, now we're talking about like 2000, whatever. But how many business people and even senior IT leaders really understand graph? And I would argue very few. So the reality is that the world is still evolving into a set of ideas. It's not good enough for me to say that they're the right ideas. That's arrogant. Actually it's even better if I push those down and say, here's your capability, here's the usability, here's the benefit from it. And if you're interested, here's actually how it comes together and how it works. But sort of the whole benefit of a declarative no code platform based on metaprogramming concepts and hypergraphs is that we separate the what you want to do from the how it gets done, right? So you don't have to know how enterprise web's mechanics to use and benefit from enterprise web, no more so than I need to understand how my car works. The engine is now fully encapsulated. If I open that engine encasement, I'll violate my warranties. And my steering wheel, my gear shifter, my speedometer are all just abstractions of what is now highly computerized. Has, I think it's over 1,000 miles of cabling in the car, right? A highly computerized uh, uh, engine and drivetrain and all of those things like that. But they're abstracted to a few devices for me to use and benefit. And I don't have to know how the engine works to drive my car,
Yeah.
right? And I'm not saying we expose it because we know engineers and technical people want to understand all the way down to the trace.
Yeah.
They won't trust it until they can trace it. So it's there, but we've gotten a lot smarter how to push technology in the background, push enablement in the foreground.
I want to highlight something and then I want to make an observation. So you said that you and Bill spent 2 years reconciling all this theory, all of these fragmented ideas that all held their own merit in a way that you can marry them and build a treatise to create the underpinning patent for enterprise web. Um, you made mention of the Swiss watchmakers. I mean, they created things that were so precise, they only needed to have maybe even a little tension tuning so that the springs can themselves perpetually keep spinning for a couple hundred years again. So that level of precision to me invokes the idea of the Japanese woodworkers that they
Hmm.
create these massive temples, structures, palaces that don't need screws. They just use joinery. They just use joinery to create maximum use and interlock parts to create an entire structure.
Yep.
It's the idea that you need to really pay attention to building the thing in your mind before you build it and implement it in the world, and that is a very difficult idea to put in the hands or put inside of the minds of people. It's easier to put a hammer in the hand of a person than it is to say, rather than using nails and hammers, we're going to do advanced joinery. And before we even do advanced joinery, we're going to think about what we're going to build and how to build it sustainably. I mean, there are paradigm shifts and layers of education that you have to meet before you can invoke the okay, I see the utility behind doing this philosophy chase of 2 years. You know, it's a requirement. You need to have some form of abstraction and acclimation to that area of like, conceptual thinking before you can really fully appreciate that mental engine that you built, that mental engine block that you put together.
Yeah, and what I enjoy about these speaking with you, especially also when we met in person, is that you're a thoughtful guy, and I appreciate that. And so you go back to the Romans. I want to say I'm trying to remember the gentleman's name, the gentleman. But this going back to the Romans, they had this notion of architecture, uh, um, st- uh, strength, beauty, um, fitness, strength, and beauty. Right. So it's and so those were the three things that they valued in architecture. So it had to fit the use case. It
Hmm.
had to and beauty I translate to elegance, right? In other words, it wasn't enough because if we're humans, we should always be aspiring to things, right? It's one of the and honestly, in our modern world, we often don't, and that's why so many buildings are drab. So much of our world we're bombarded by
Well,
mediocrity.
now it's becoming easy and acceptable to be mediocre in beauty. But before, with the Victorian era, with the crown molding and the plaster, um, that was an elevated form of human expression. But
Yeah,
I hear you.
yeah.
Sorry.
People were doing things uh, for because they could, and they were doing them because they wanted to get a better experience out of it. It goes back to that, right? They were like, well, just don't build thing. Don't. It's not building for building's sake, right? It's not a gratuitous action. We build for these properties. It's a these are they become motivating principles, right? And in software, that translates to design elegance, and design elegance in software translates down to power of expression relative to code base, right? How expressive can you get in how small a package? That effectively is the definition of design elegance in software, because it becomes there's I think it's Saint Aubrey d'Expert is a French philosopher who said things aren't finished when you can't add anything more. Things are finished when there's nothing left to remove.
Yeah.
Right. So I want to say it's Saint Aubrey Exubry.
Nikki
Um,
Nikki Clark put in the chat Vitruvius. Vitruvius?
Vitruvius. Yeah, yeah, yeah. Because virtue was value or fitness, and it is Vitruvius is the Roman philosopher. Thank you, Nikki. Um, and that was buried in some dark cobweb of my own mind. But yeah, so I think that when you can get that kind of compression, right, then compression equals power, right? It's actually then goes back again philosophically. Now it's leverage, right? If I had a long enough lever, I could move the world, right? That's we're I don't know if the audience is following all this, or if this is interesting. Whereas
I love it. I love
we
it.
wax poetic, but
No, I love it.
this is that's what it is. If I have something really compressed yet powerful and expressive, then that's leverage for me, because now, well, actually, I can take that software and I can put it at the edge, I can put it on a device, I can put it on a phone, I can put it in different locations, and it can retains its power in different contexts, and that's leverage, and leverage is engineering, right? And this is so they're just in some ways they're the right way to do things, but there's a lot of reasons why in the real world people don't have the opportunity to do the right thing. It is somewhat. Bill and I had sort of an indulgent experience, the ability to sit and just be able to focus and do something over a span of years with no income coming in, right?
Yeah.
Just be able to do that with no artificial pressures. Nobody telling us, "Hey, Dave, you have to pivot this way. Dave, you have to scale down your ideas." Actually, plenty of people told me to scale down my ideas, and I just ignored them.
I see it. I just want to show you that someone's encouraging you to keep going down the poetry and the
Thank you,
philosophy.
Joseph.
Thank you, Joe. Yeah, man. There's absolutely no reason to not delve into these areas because this is the foundation of what it is that informs you to construct that lever to give you leverage. That is the way to do it. I mean, you have to take the time to sharpen your axe before you chop the tree. You have to make a long lever that's resilient, robust, so that you can bend whatever you want to bend or get the leverage that you need. If you implement with your fingertips and you try to pull apart something, you're going to end up having bloody fingertips, and you're going to, have splinters and hurt yourself. It's brittle. It's brutal. It's raw, and that's okay. But when you want to really construct something that has the true spirit of an engineer or of an architect, you require to reform your thought around what it is that you're trying to accomplish and make it fit for use and make it robust and make it beautiful, right? It's a creative expression.
Yeah, and it takes a lot of. First of all, you have to have a vision, a really clear vision, right? Then you have to execute on that vision almost ruthlessly. Because it takes a tremendous amount of rigor and discipline to execute that way, right? Because if you if you yielded to any specific request to do something less than the right thing, you'd end up with the wrong thing, right? So in the journey of building the core platform, right now, the core platform is extendable in a million different ways because we built it right. but so it's an enabling technology. That's what enterprise web is. It's a platform for you to now go forth and build your ontologies and build your visions and your systems on top of, right? That's enterprise web is not a enterprise web implements a set of software constraints so that our customers can have flexible futures, right? Flexible and agile and contextual and intelligent futures. That so the way you do that is, if you look at the way systems are built today, when you hard code systems and you do things imperatively, essentially there's always a model. Even hard code has a model,
Hmm.
but the model in hard code is
Very
implicit. It's in the code. It's
Mhm.
not explicit in the model. So when something breaks in code, you have to read the code, right? It's not declarative by nature, and of course, if you build things of lots of different code, you're building a hodgepodge, a bolt-on architecture of lots of different ideas that actually might not come together in a very natural way. But that is the way people build things because it's tactical, right? They're like, hey, I need events, bolt on an event engine. I need policies, bolt on a policy engine. Oh, you know what? AI, I need AI, bolt on AI. And then they wonder why they never achieve their broader goals, right? And you see this every day, like, oh, gee, we just spent 10 years and none of our AI initiatives have really delivered what they want. It's like, well, you didn't have the right models and capabilities to support that AI. The algorithm is not bad, but the algorithm wants to roam free, right? The algorithm wants to, like, it wants to support, it wants to reason over a broad, it wants to evaluate state over a broad space. And if you give it a narrow siloed space, then you've set the rate limiter for what that algorithm can do. So if you want if you want solutions to big end-to-end problems, you need big models that are both wide and deep. So, like, just to use a telco analogy, in telco, enterprise web literally goes. There's something called the OSI layers, right? The protocol stack of the telecoms, and it goes from layer 1 to layer 7. So it goes all the way down to the very physical, all the way up to the application layer, to the completely virtual. Um, and well, most companies build technologies within different layers of that stack, right? And then, but wait, within that stack, there's also silos. So in telecom, particularly, you have what's called the radio access network, you have the core network, you have the what they call the transport domain. Well, those become the three primary pillars of a telco: RAN, core, and transport across layers 1 through 7. Well, you just created a matrix architecture, right? Silo verticals against layers. Guess what? For every box in that matrix, they have different technologies, and then they have technologies laterally in a layer, and then they have technologies vertically, and then they try to vertically integrate that all together. Those technologies aren't from the same vendors. They're not from. They don't. They're not updated at the same time scale. They don't have the same. They don't share a common model. So what's going to happen is they're going to break all the time. And you're not going to have end-to-end visibility. You're not going to have end-to-end automation. You're not going to have end-to-end policy control. So in enterprise web, our graph model in under 50 megabytes, so the footprint of enterprise web, it give you that sense of that compression, is about the kernel of enterprise web is about 6-7 megabytes, right? 6 to 7 megabytes. The entire platform, including the telco domain model, which I would argue is one of the biggest models. I mean, there are obviously big domains, but telecom domain model is a very complex domain because not only does it include sort of the higher level application level concerns that a business might have, it also includes all the cloud concerns that everybody and infrastructure at the cloud level that everybody has regarding resources. It also has the concerns of the network itself that pretty much nobody else has other than a telco, right? Which is to provide the network, which connects the systems, which implement your applications. Enterprise web implements that all in 50 megabytes, right? We can provide transparency over that whole space in 50 megabytes.
I think
That's elegant.
I think the way that we live in the world today is a consequence of the education that we process minds through. At a university level, they teach you algorithms, they teach you how to solve a bubble sort and find the prime number. Um, there's a lot of things that are looking at ways to solve problems with computer science. but I don't really see, and this is due to my own ignorance of the academic world, where are the computer science architecture schools of thought that are bringing people to higher levels of thinking outside of just implementation details? I think we're living in a world of carpenters when we need to be elevating it to a world of architects, because it's, as you said, bolt-on architecture. It's stacks. It's build the database, build the data, get select database, build the schema, right? According to the constraints of what you know today. Not to say that the business will expand or contract over time, but you model it for that. Okay, build an ORM or create some sort of backend API layer, and then connect that to the front end and make the front end strictly coupled to the API and the API strictly coupled to the database. And you have this bolt-on architecture. Heaven forbid you have CRM systems that you want to integrate with, or you have some other proprietary or systems that you're subscribing to, that you're paying a subscription to, that you have to adhere to their own architecture, to their own practices, to their own limitations. You're just creating this huge ball of technical debt, and overhead of operational taxing, of thinking about how to adhere to all these different patterns. It it makes sense to take 2 years to really go down the rabbit hole of how to figure out how to reconcile all these thoughts so that you can make a precise watch out of a system. It makes sense why it's so compressed. You really thought about how to get rid of all the stupid libraries that bloat software. I saw someone post as a meme, as a joke, is even as a freaking npm library. I
Yeah.
wanted to claw my eyes at it. I just didn't understand how somebody could like, and it was widely used. Somebody could not just reason if there is some sort of remainder from dividing by two or something like that. Why is that? Why does that exist? It just doesn't make any sense to me. You know.
Yeah, and there's an interesting. So that was a lot. So let me unpack a little bit. But a really good thread. But one fundamental truism is that the more complex your systems, the less elegant they are, the less rich your end users' interactions. It's a paradox, right? It's not really a paradox. It's actually almost intuitively logical. So if you build these crazy systems, which is what we have today, right, which are all kludged together, right, that have all this overhead, lack of interoperability, lack of real-time contextualization, and all those things like that. What you're doing, and they're all hard-coded and imperative, right? Or maybe there's models, but there's many models, and there's no integration between the models, and the models are changing at different times, and nobody cared to synchronize models, and right. The problem is, that's a big ball of mud, right? That big ball of mud is gonna get in the way from the customer experiences that everybody wants today, right? And I think that's why, honestly, we've sort of been in the wilderness for a while, and I would argue that's where all powerful ideas come from. All powerful transformative ideas, they don't come from the center. They don't come from because the center is the status quo, right? All powerful ideas come from the periphery, right? In this case, it happens to come from upstate New York, Glens Falls, New York, where I am happily based. But they come from the wilderness because it's only in the wilderness where you have time to sit and reflect, where you're not under the pressures of the center to conform, right, or to react. And so we were able to spend time, but for a while in our beginning years, we were presenting demos, and people were saying, "Oh, this is architecture," even though I just demoed it, or they were like, "This is BS. You can't do that." I'm like, I just showed it to you. I just did it in front of you. I'm taking you into the back end. I'm showing you how it's connected. What do you mean I didn't do it? Like, what do I need? Do I need to bleed for you? I don't know. And but I think it's really important for people thinking about why their enterprises are stuck. For enterprise architects, for IT architects, for C-suite folks, it's a function of your systems. And if your systems are overly complex, they're detracting from the interactions that you want. Your end goal is complex interactions, right? Like we're having today, right? This conversation is a complex interaction. And so we want that. Now, go back to the academia thing. It's sort of funny. Is that what does it mean to be an academic? What is a PhD, right? It's a degree in philosophy, right?
Mm.
That was a PhD is. It originally meant that you were a broad student, a master of a body of knowledge, right? And it was the whole point originally was it was a broad body of knowledge. You were a lateral thinker over a domain. But that's not what academia is today. I mean, so let's not even forget all. I mean, there's a lot of problems in academia, and we're not going to solve those today. I'm going to focus on the one that's relevant here.
We're at 35 minutes in. I want to put on the boxing gloves a little bit, and I want to exercise. I want to really exercise the Q&A here. So your prediction is this is the year of the graph.
Yes,
Period.
period.
Why? Let's go into that. Why?
It's because you just think about it in a span of a year, because undeniably 2023 was the year of generative AI, right? From nothing to everything to inescapable, right?
Yeah.
I mean, I don't know. Do you get a Medium feed, blog feed, and all these other feeds? And it's like it went overnight from a wide variety of articles that could have been anything to my entire feed is 90% Gen AI,
AI. Yeah. Gen AI.
right? And if I have in a lot of conversations, Gen AI, Gen AI, Gen AI, Gen AI. But it went from, and remember, it wasn't even the full year. It was like March, April, right? When it really hit. And became part of the public consciousness. Obviously, generative AI goes back literally decades. It's 50, 60 years. The algorithms have been in the development. The thinking about deep learning and things like that. That's a long gestation. But in its most modern implementations have been around for 2, 3, 5 years. So it just felt like it came out of nowhere, but obviously it didn't. Just like enterprise web doesn't come out of nowhere. We've been long in the journey to be now what we believe in the right place at the right time. But why now? Because by the end of 2023, even my children understood that Gen AI had problems, right, with correctness, consistency, right? Like so, they're not children really anymore; they're young adults. But my my salt and pepper beard belies my age. But but it became widely in the span of 6, 8 months. Everybody understood like Gen AI is going to change the world to like, whoa, Gen AI has some issues. We love these ideas. It's stimulating lots of ideas. But let's think about correctness, consistency, IP, copyright, security, latency, and cost.
Yeah.
And energy efficiency. Let's not forget that when you have the hyperscalers now considering building nuclear power plants
Mm.
because that's how consumptive this stuff is. And hey, go figure. To parse the entire world web is energy consumptive. Like newsflash. Yeah, it's a brute force task. I mean, and it's so I'm not against generative AI. I'm not against deep learning. I'm not a Luddite. I honestly think that you have to with any technology like that, you have to balance its strengths while mitigating its weaknesses, right? For practical solutions, right? There are things it brings that are unique, novel, and powerful that we'd like to leverage. I'm pretty sure that safety and correctness will still matter in the 21st century. I'm pretty sure the enterprise doesn't want its ERP systems to hallucinate. You're talking about some real serious issues that just have to be managed. And in enterprise web, we've already won awards for our collaboration with Microsoft on telco grade generative AI for intent-based orchestration. So we're already doing pioneering stuff on this front, and what we're doing behind the scenes is already ahead. Think about this. By the time that GPT-3 or so was announced around March of last year, it was before, by May, Enterprise Web already had a full-blown demonstration taking our hypergraph, and using it to provide context to ground interactions with LLMs. And we had that by May. I was demonstrating it on, I think, May 5th at a conference of last year. It's still unanswered. No one has replicated our demo.
Let's talk about that. Let's dive deeper into that hypergraph. What is the difference between that and commercially available graph technology today?
Okay.
And also how is that different from structured databases and things like that?
Yeah. Okay. So again, just taking off from 2023 being the year of Gen AI to why it's now the year of graph, and it's more than graph, but I think graph is a unifying. It's a theory. Graph is a theory. So when we could speak about graph in the general, right, and it's inclusive of semantic web, LBG, and hypergraph, right, and then we could talk about the distinctions between different kinds of graphs. Um, but the reason why fundamentally graph is going to 2024 is the year of the graph is because everyone is having almost an awakening. If you think of generative AI creating market pressure on every boardroom saying, what the hell are you going to do with that? Right? We
Yeah.
can't, you're at risk of being disintermediated. If our competitions or a new digital native company comes out and models our domain, we could be completely disintermediated. And look, that's happened before. Think of Airbnb. Think of other companies that come out of the blue, seemingly, and just take over an entire market,
Do you eat your lunch? Yeah.
right? And eat your lunch. Now, they might not come. None of those journeys tend to be overnight journeys, right? But when they succeed, Joaquin, that's why they call it disruption. Nobody sees the punch coming, right? Because they weren't watching it. They weren't watching. They weren't paying attention. They didn't have their eye on the ball, right? And so when they get right,
Blockbuster, what else? Kodak. They have they're closest to the action and they have the capacity to invest in R&D and stay ahead of the curve, but they through organizational political battles stay within a inertia of movement of innovation.
yeah. So my one of my early career stints was working with one of the largest digital graphics companies, and we were the biggest consumer of Kodak product professionally in the world. And so I had many occasions to meet with people in Kodak in Rochester. I can tell you from firsthand knowledge, visiting Rochester in Kodak's headquarters in 1995 or so, you could smell death. You could smell corporate death. It's just, you know what it is. Yeah, they have the largesse, but largesse doesn't account for much, right? They had the largesse to do whatever they wanted, but they couldn't get out of their own way. And how doesn't that characterize many of our largest corporations today? They can't get out of their own way. They are their own worst enemy because instead of being the drivers and change and transformation and new value for their customers, they're the keepers of the status quo, right? Because they build up these things. Let's go back. Let's go back to graphs.
I just yeah,
You're as bad on tangents as I am.
no, I'm good with tangents. I like them.
Okay, but it brings out the worst in me because I'll walk down these threads with you, and hopefully people can follow.
Give me 20 seconds, and I just want to add something to that. I really like Procter and Gamble because they implement corporate Darwinism. They bake products and they create competitive products to temper and test the market against their own successful products. So I really appreciate that strategy of how they build companies and build their portfolios and have companies flourish or die, but they do that deliberately. They don't make themselves into one whole and wait and hope that everything's going to happen and they don't need to change over time with advances in technology or theory. I just wanted to add to that. Please proceed, unless you want to add to that. And then
No, well, it's still good score. I'm not going to let go of hyperscale, hypergraph. So I'll get back to that. But so I think what it boils back down to is culture, right? And so we know that big, large corporations tend to be hierarchical, and then you have Conway's law. Your solutions model the culture of your organization, right? So there's a lot of reasons why they can't almost escape them. It's perverse incentives. When you have a big siloed hierarchical organization, people keep to their silos. They're not incentivized to think across silos. If you sort of step out, now you're a troublemaker. They tend to corporations are trying to adopt ideas like intrapreneurship, where you actually have people that try to bring people together across units, and that's a very positive thing. Entrepreneurship, and so I think corporations want this. They're struggling to get there, And this is now, why is 2024 the year of the graph? The reason year 2024 is the year of the graph is pretty much market pressure, board pressure, C-suite pressure, pressure on units, right? That is the force that's driving change. And the one unifying thing that I think people look at Gen AI, let's talk about Gen AI again for a second. 2023. By the end of 2023, in the span of 6-9 months, not only people understand Gen AI, understood where the idea space it was creating, where the new possibilities, as far as human computer interaction, but they were also saw the faults. And the other thing that they realized was there won't be just one Gen AI, right? There won't be just one algorithm. Just like an AI. I mean, what is AI? AI is an algorithm. You'll have lots of algorithms. And now we realize already in the span, that's a very rapid learning curve, right? Not just for you and me, but almost our entire societies and cultures are like, oh yeah, I'll have open source LLMs, and I'll have small learning models, SLMs, and I'll have deep learning that I can deploy at the edge. Well, guess what? Now you're actually saying that the LLM is not the center of the universe. It's a capability.
Right.
What is the center of the universe? It's your graph domain model. And honestly, conceptually, it should have always been. Sorry about that. I thought I had my phone off. Let me turn that ringer off. In 2024, I think there's a growing awareness that the central asset of the organization is the model it has of its organization. It's people, information, and capabilities. The absence of a model of your people, information, and capabilities and how they flexibly connect for purpose is your rate limiter for everything you want to do.
Yeah.
And it doesn't mean the silos all burn down tomorrow. It doesn't mean you're burning down your brownfields. It's none of that. I am the last person to assert fear, uncertainty, and doubt. That is the primary strategy of legacy companies. No, you start with abstraction and you say, hey, no matter what you're going to do, you're going to want end-to-end abstractions that go wide and deep that help you connect your enterprise. And it can connect your existing structures and it can connect your existing tools. Layer one, right? Step one, get that model in place. And by the way, Rome wasn't built in a day. That scope of that model doesn't have to go all the way down and all the way across in a day. An enterprise can start off by saying, you know what, actually, I love all these ideas. I completely buy into it. This is my vision, but I want to start with a platform that enabling technology. And let me start off with a fixed scope, a narrower scope of breadth and depth that proves the use case, that proves the utility, that proves the practical application of that technology. Great. So let's start with a division. Let's start with a department. Let's start with a single use case. And we'll connect those elements. We'll show how we did it for them. Then, because it's a graph, and inherently graphs are flexible and extensible and adaptable, I just extend the abstraction to other lines of business and other use cases and other things. So that's what graphs should do for people. Not all graphs can do that. And that's when we go into hypergraph.
There's a question that's come into the chat from Alan S. Michaels, and he's asking, how much of an enterprise knowledge graph, enterprise web? I think we need to disentangle those terms, but could you theoretically build for a company like P&G without talking to them? You just have a list of the products they make and the services they provide, aka start with a clean slate. And then I'm thinking this is from the perspective of a market intelligence or market research. Alan, is that correct? Well, I'll let you get started on that question.
It wouldn't matter. Let's just take B&G operationally or whatever, from whatever aspect. It doesn't really matter. Great question, Alan. And of course, Alan, I appreciate you joining the call today. He's recognized in his own regard. So it's a great segue from where we were, right? So we were just talking about like start at the scope of interest, right? Something tractable that a customer can bite off of. Now, enterprise web starts off, Alan, let me do a little bit of the layer cake here so you can appreciate it, or especially for the audience, you might already know. But enterprise web starts up with an upper ontology. That upper ontology is the physics of enterprise web itself. Enterprise web is a function of the graph. Enterprise web eats its own dog food. There is nothing but graph in enterprise web. Enterprise web is a graph that includes behavior, so it's an executable graph. It's a DSL. And enterprise web, it's our own capabilities. Let's call that the micro flow. If we look at the functional requirements of a business, your business process, your flow chart, whatever it is, right? That's the macro flow. That's the higher level process. If you think about what middleware does, it's the micro flow. It's the internal process of delivering the micro flow. That's recursive, right? Enterprise web starts off with an enterprise upper ontology. It describes how enterprise web exists itself. Then inside that upper ontology, it also includes two other things. It includes a generic enterprise domain model, which includes things like we know what units are, people are, facilities, all the things that apply universally to all organizations that any organization can map into. A sort of minimum viable data model of an enterprise, let's call it, right? It's not canonical. In other words, we're not pushing it down. We map things up. So people could come in with their own terms underneath, right? Same thing we do. We have a type system. This is a very unique, another reason why we implement Hypergraph. Enterprise web has a rich model of system behavior, right? That's what we've really pioneered, is a graph that implements not just data structures, but it's actually declarative expressions, right? So that you now, in software, you call that homo-iconic, right? Homo-iconicity. Data and code are described the same way in one system. That means data can be an input to functions, and functions can be an input to functions. That allows me to create pipelines dynamically. Now that means I can dynamically construct data flow pipelines on the fly based on interaction context for every single user at scale. I just described enterprise web, right? That's called meta programming. But that upper ontology is a model of enterprise web's own internal physics combined with a generic model of an enterprise and a very deep type system, protocols, formats, schemas. We understand how all those things relate. And so that having those things together essentially makes our upper ontology a DSL for DSLs. With enterprise web's upper ontology, which is a hypergraph, we can build domain-specific graphs, let's say one for P&G, or more broadly for life sciences or for commercial products or whatever else it is. And so we can then take another ontology and plug it into that layer. Now, you can build that from scratch manually in enterprise web if you wanted to, but that wouldn't be the recommended way. We could probably take a model from Alan, because Alan's done tremendous work in that regard, and we could ingest that, right? No matter what logical form that Alan has created in that, whether it's RDF, LPG, doesn't matter to enterprise web. We'll do entity extraction and algorithmic mapping, and we'll throw it up against our upper ontology, and we'll create a DSL of Alan's model or whatever else the customer starts with. This happens all the time. We do this all of the time, where in the telco domain, we had a customer give us their entire information model as a JSON file. And we literally extracted it and brought it into our hypergraph. So we didn't just copy the file. We take that model, we extract that model, and we implement their model in our language, because enterprise web is metaprogramming. It's a higher order logic. If things like LPG and semantic web are first order logic, higher order logic languages can consume lower level logic languages. So it's very easy. I mean, honestly, we even can import pseudo UML, right? Which is what 90% of standards bodies do. They don't even do anything formal. Like, they don't even do formal rigorous UML. They don't even do formal RDF or semantic web or LPG. They'll do like, oh, here's some pretty boxes. And we've taken Word documents from standards bodies, ingested that and projected it back out as a graph. And we do that literally in seconds. And of course, it's all weighted and scored. It's all algorithmic. So, clearly before implementing that as a system, you'd want somebody to go through it and check out the mappings and things like that. But it's like a 90+%, 95% accurate mapping system, right? And that enterprise web does. So that was Alan, that was a long-winded response, but I wanted to give you an idea. Oh, and then the next level, so if you think of this as a layer cake, upper ontology DSL for DSLs, then the customer's DSL, and actually that should be really interesting to any graph people on the line, because my use of the term DSL isn't. Graph databases aren't DSLs, right? They're data models. We're raising graph to hypergraph to provide an abstraction to the developers, which is a DSL, so that it's executable for behavior. That's we walked just now, just an intellectual layer cake, right? And so upper ontology to the customer's domain model, PNG, or an industry-wide model, or a true meta model. We can implement that there too. Like, there are people out there who have built generic models, and we can implement that level, and we essentially be mapping it up to Enterprise Web's physics of the upper ontology. And then below that is actually the domain objects, which are in Enterprise Web. They're abstract data types. They're graph objects that map up to the domain, which maps up to the upper ontology. So now just think of what we just did there. We have an upper ontology that supports the creation of domains. The domains support the representation in metadata of domain-specific objects. That's a logical separation of concerns that is just good architecture. It's a nice layered architecture, but it's actually just really one graph. In Enterprise Web, our mechanism doesn't see 3 different graphs. It just says domain objects map to domain models, which map up to upper ontology. When I'm processing something, I flatten that graph. Excuse me if that got on the pickup, if that was really loud. But I can flatten that graph, so efficiently, because graph has mathematical properties of adjacency, associativity, commutativity, right? We can apply all the graph principles, because in a real graph, Enterprise Web is effectively implementing a sparse matrix. There is no distance between elements, no matter of parent-child degree. Like, we're not building trees, right? RDF and LPG build trees, right? Which means you're walking trees. In Enterprise Web, if it's a 3rd degree separation, 10th degree separation, 100th degree separation, it doesn't matter to Enterprise Web. No 2 points are more than 1 hop away. So that's adjacency. And it would actually be good to see if Alan was happy with that response.
I just want to say, yes, you can make a enterprise knowledge graph. I just want to boil that down to yes, it is possible. And you could start iteratively with what they give you. You have a model of what is the generic underpinnings of enterprise. You just need to map it to that. And as you uncover more information and you express the way that the company functions, you can expand that and make that more expressive.
And actually, everything's loosely coupled. So, a couple other things that are really big distinction is the graph is every object in our graph is loosely coupled from every other object, including. So, if you think of it, a single domain object itself could be a complex set of relationships. It might have dependencies, constraints, right? All sorts of things. It's going to have properties and interfaces, all sorts of things like that all get modeled in Enterprise Web. So that's a complex graph in itself. And I raise that to a business service, right? That's now a set or a collection of objects. A service is a higher order object, right? It's again an abstract data type and a graph object. It's now a set of complex relationships. That set of complex relationships is a set of independent elements that collectively produce a single unified service, but they're independent, so they have to evolve independently. So you have to have history. You have to have an immutable history. So now this gets really interesting, because you can't do that in LPG and RDF, right? So now we've got history, we've got behavior, we've got cross-cutting concerns, all being implemented as dimensions on that hypergraph, right? And that also gives us tremendous compression, because hypergraphs can be compressed. They're super hyper efficient, where LPG and RDF are actually build out physical graph databases. Enterprise Web implements as a long skinny table. And so long skinny tables are the most efficient storage model in the universe. And so we can project graphs from long skinny tables to understand something and its relationships really very efficiently, and then take contextual action against it in the moment, record all of that in an append-only immutable log style store, which gives us history, trace of all activity that the system did. Et cetera. So, we went from this winding philosophical road to where the rubber hits the road here. And I hope everybody's still with us. But
I think
anybody out there want to give us some feedback? Are you still there, people?
I just want to add to that the difference between commercially um, graph database solutions that currently exist on the market that, as you said, create a physical tree structure versus hypergraphs is the way that it's mathematically modeled. I think the the graph database express things in solidified data structures, so things are explicitly linked together, right? But the way that you
Explicitly and effectively physically as it's persisted, right? And
like
that becomes a problem on
that's a
scaling,
rigidity. That's a rigidity.
read write efficiency. You've got there's very specific. We talked about this in the last interview, so I won't go long on it. But in the last interview, and actually I have a blog post coming out on this soon as well. Just objectively, again, these are not. If you remember what I said only a few minutes ago, I actually pointed out that like enterprise web can ingest RDF and LPG. So a good model is a good model. It's a good model is a value proposition, right? So those are still good tools for building logical models. What they are not and will never be, because of their very specific architectures, they will never be real-time operational systems.
They're not efficiently. You can't efficiently process them the way that they're implemented in the physical state that they're in.
Because an application developer needs that context at millisecond speed, right? It needs to be scalable, elastic. It needs history. They need cross-cutting concerns. There has to be security, identity wrapping all of that. You need transactional guarantees. You need all that stuff. Those things where data models, RPG and RDF, are data models for data scientists. They support recommendations. They support analytics. There's a whole bunch of use cases, none of which I'm dismissing. We really aren't those things, right? They veer towards the OLAP side. And while some of them will say, oh, we have an OLTP interface, that's a bit specious, to be honest, because an OLTP, if you might have an OLTP interface, but you're not going to be an operational database, right? Enterprise web is an operational persistence model abstracted over the storage. So we can run over any storage. We generally run over Cassandra. When we run a Cassandra, we run over Cosmos. We can run over any columnar store. So the storage level is completely abstracted away. That's a whole nother value proposition in enterprise web. We don't want people to think about graph databases. We don't want to have to think about tuning queries in advance and optimizations of their, right? That's crazy. No developer wants to do that. They've got enough to do. So our motivations, enterprise web is designed to do what it does because we're motivated to deliver real-time, complex, contextual operational systems. That's our bias, right? It's our motivation and our bias. That doesn't make it a slight on anything else, but I think it's fair to compare ourselves to those other technologies so people understand the distinction, right? I think the industry needs that. I was like, oh, okay, these tools are fit for this purpose. These tools are fit for that purpose. So I'm not, again, fear, uncertainty, doubt is not my modus. And to me, I think of ecosystems and connectivity and how things come together for meaningful purpose. I'm a business guy. It's just how I think.
I have one quick question for Bill.
My silent partner.
Yeah, I want to throw a question out to Bill. Can you tell us a little bit more about the work that you did in reconciling that handbook, workflow management, on dynamic interoperability, particularly in that context? We don't have to go into the context of what you wrote, but like, what was the thinking behind that, and how did that, inform your contributions to this hypergraph model?
Okay, well, yeah, so rolling way back, what I was looking at was dynamic workflow in a healthcare setting, right? So and this is, rolling back now a number of years. At the time, the state of the art was kind of BPL and BPMN processes that were, I don't know, pre-optimized or pre-planned. Everything was either a static workflow to get to your result or effectively I say it, a code first application that someone wrote specifically for the domain. So there was no in between. And when you looked at model driven architectures and so on, it was a very pre-planned thing. You wrote a whole bunch of UML, hit a button, and then you were left with a bunch of code that you modified. So there was no in between. So what we looked at that time was, how do you effectively build a system that's actually going to work with context as it unfolds? So how do you build a workflow step by step? And really, if you think about what Dave has just described, we built a machine that walks a hypergraph in real time to solve these problems. So it takes into account a vast amount of context at every step, at every click. So that's in a nutshell. That's how that original ideas and I guess research really have found a practical implementation with Enterprise Web.
Appreciate that. Thank you.
No
and that's a good recollection because it goes back, but that was the kernel, right? And then of course and when you think about what two words that Bill said was process and context, right? That's where abstraction hits behavior, right? Because Bill's background in high-level generative programming and metaprogramming was a natural fit for the ideas I wanted to implement, because I wanted abstractions to drive contextual behavior. I wanted to have things be very hyper efficient. And there were no implementations like us. There's still no real implementations like us, but it wasn't easy to do because we had to solve a lot of problems along the way, and we couldn't put anything out until we solved a set of problems. And while this is an abused metaphor, it's sort of like a moonshot. You don't go to the moon by designing the astronaut's uniform first, right? You go to the moon by saying, geez, how do I get this thing off the planet, out of our atmosphere, on a trajectory to orbit the moon, take a lunar lander, shoot that out of this rocket, let it land on the surface roughly where we expect it to land, with humans on it, bring those humans back to mate back up with their orbiter, and bring that back on a trajectory that hits a window on the Earth that's the size of a sheet of paper. And if it doesn't hit that sheet of paper, it either burns up in the upper atmosphere or it skips off the atmosphere of the Earth and goes hopelessly into outer space. Well, so you think about the hard problems. And there's this guy, Astro Teller, who ran the Google X Lab, who has a series of papers on solving the hard problems first. Which are really good reading. So Bill and I sat and we solved the hard problems first, and everything else became easier, right? And now we do POCs and demos in like 2 days, right? I mean, for really big problems, people call us up, hey, can you do this? Yes. But it's because we did a lot of the stuff up front, it makes the back end easier, right? Make things elegant up front, and you support more futures. If you are doing everything in a very imperative kind of way, if you're doing everything in a very procedural way, you're actually working against your futures, right? You are actually, the technical term is prematurely optimized. You're optimizing for the design time of the designer as opposed to the runtime of the user, right? Context is inherently about the runtime experience, the real-time experience of a user or a system going through a set of actions or experiences. So that means the system, you're doing what's called an inversion of control. I am actually flipping the switch on the system. So it's, instead of being all hard-coded, what I want you to do, I'm changing the system to react to what you're trying to do, help optimize that along the way. And yes, I'm applying policies, tools saying, no, you can't do that, or no, you can't go in that direction, or that's unsafe, or this is the most optimized path, go here. But the idea is, inverting that control so that context and experience drive implementation, not implementation constrain experience.
Dave, you say I'm a bad host because I let you run on these tangents, but you have a lot of knowledge to drop, and I've certainly appreciated this whole conversation. I hope that the audience that has been tuning in and they've been keeping a pulse check on this. They get as much value as I did out of this conversation. and certainly it'll be available for people to come in and view it at their leisure, later in the evening when they get out of work or whatever. But feel free to reach out to Dave Dugal and Bill Malik for anything that you have to do with, implementing uh, a clear business use case with a super fast ROI as to what it is that you're trying to do with knowledge graphs or modeling or ontology. They're the people that can certainly sort you out in a week or so.
Yeah, and also we just enjoy good conversations with smart people. There's a lot of people in this industry who have a lot of ideas, and so in general, Joaquin, you can see we enjoy talking about these things. We're passionate about it, and so we like working with our peers in industry, and because the industry is gonna evolve through conversations like this, and I think that's critical. And I appreciate you hosting me and many other people that I know and some I don't know for your interviews.
Well, with that, we conclude this stream.
Thank you.